starting with this. So equivalent capacitance. So in this case, these two in parallel, we replace them in the equivalent form. And after replacing these two become in series, we can replace with the equivalent form. Do you all follow that all three have some similarity? All three cases, the behavior of system between X and Y in all three cases are same. So all three behave like these two capacitors, and these two also behave like this one single capacitor. So this case, suppose I have to find what is the charge the battery will send. I cannot find. But when I come to the third case, can I find what is the charge which the battery will transfer from the negative plate to positive plate? Now I can calculate. Because to apply the formula, I need only one capacitor. So in this case, how much charge the battery will transform from negative plate of this capacitors? How much charge will transfer from negative plate to positive plate? Can we calculate that value? Charge is equal to CV. It will transfer a charge equal to 200 microcoulomb. So this plate will have, lower plate will have the plate which is connected to negative terminal of battery will have minus 200 microcoulomb charge, and positive plate will have plus 200 microcoulomb charge. Or charge transferred by battery in this direction will be 200 microcoulomb. What does this mean? Okay, charge from battery is 200, sorry, not charge, not microfarad, it should be microcoulomb. So all this cases, and unit I have got wrong, so all microcoulomb. So what we know, if this is 200 microcoulomb, this also will be 200 microcoulomb, and this also will be 200 microcoulomb. Okay, as far as battery is concerned, all three behave same. So what you understand here, so if this is 200, this also is 200. Now these two are connected in series. So in case of series, whatever charge is transferred by the battery, both the capacitors connected in series will receive the same charge. So what is the charge on 30 microfarad capacitor? 200 microcoulomb. How much this will have? This also will have 200 microcoulomb. So charge on both will have charge of 200. This also will have 200. This also will have 200. So from here, this is now. What is this 30 microfarad? 30 microfarad, this capacitor is actually a replacement of these two. So whatever charge this capacitor has received, this 200 microcoulomb, actually this is some of the charge received by these two capacitors. So these two put together will receive a charge of 200 microcoulomb. But how would this charge get distributed? How is the charge distributed?
Direct
in which
proportion.
Directly proportional. So this will get 1/3 of the total charge. This will get 2/3 of the total charge. So the total charge received by equivalent capacitor is 200 microcoulomb. This will be 1/3 of that. Other will be 1/3 of that. Charge will be shared in proportion of capacitance. This will be 200 by 3. That will be 400 by 3. So what we have done with this method, we have found out charge on all three capacitors. If we have found the charge, we can find out potential difference. That's called solving a circuit. Anybody has a question on this so far? So what we did, first we went in the downward direction, and again we went back in the upward direction. We went in the downward direction to find an equivalent capacitance. After finding equivalent capacitance, we found what is the charge which is supplied by the battery. Once we knew the charge, the same charge 200 here also, and here also. Based on that, we worked back what is the distribution of charge on each capacitor is. And you pay attention, follow now or revise this one, see that you understand this part well. It's nothing complicated, simple method we follow, we'll get this answers. Okay. Now potential also, if you have to calculate, if this potential is 0, can we find potential at point Z? How do we find potential at point Z? So this here, which upper plate will have positive charge, lower plate will have negative charge. So potential difference across V is equal to what? V is equal to Q by C. So V is equal to Q by C. So I can apply this to find potential at point Z. Potential of 60 microfarad capacitor is equal to charge by its capacitance, which is 100 by 3 volts. 100 by 3 volts is Vz minus Vy. Vy is 0 because Vy is same as potential of the negative plate of the battery, which implies Vz is equal to 100 by 3. Gayatri?
Yes, sir.
You have followed?
Yes, sir.
Meghna? Kevin,
Yes, sir.
are you okay so far?
Yes, sir.
Kartikeya?
Yes, sir.
Okay. Now, this is basically the 2 points only we are applying. Okay. If you're okay, then we'll proceed further. Now, Kevin, let me ask you. How many capacitors you see in this question?
4, sir.
4 capacitors. And so this is something, so rather than giving a number, we have used a variable. Sometimes capacitance can be written in form of CCC. One is C, 2C, 3C, 4C. It becomes easy to identify. If I ask you, find equivalent capacitance of this 4 capacitors. Can we find equivalent capacitance here? Is anything missing? Something is missing. If I say
The potential points.
we have to define the points. Because of how it will be connected to circuit or where would the battery be connected, that's important. If we say find the equivalent capacitance for same 4 set of capacitors, it appear like it is connected in form of a square or whatever shape, rectangular shape. But this itself, we cannot find capacitance. We need to define which point across which the battery will be connected or across which 2 points capacitance need to be formed. First thing, for parallel series, we can't say anything until we must define where it is connected. So now I say find equivalent capacitance between A and E. Now it becomes a proper question. So what does it mean? If the battery is connected, it doesn't matter which is positive, which is negative. Both side capacitors behave in the same way. Okay. So if I connect positive at A, negative at E, still the capacitance, if it comes to C equivalent, if I connect it other way around, also will come to the same thing. So find equivalent capacitance between A and E. If this is a question given, I need to, even if battery is not drawn, I need to visualize a battery connected across A and E. That makes it easy, because what will happen if I don't draw a battery? If in this case, I ask some of you, are C and 2C connected in series? If you look at this, it will appear as if they're connected in series, because battery has not been drawn yet.
Branching is happening.
So what happens the moment I connect battery, and now I notice, okay, these two are not connected in series. Okay, there's a branch in between. Now we look at this. So first of all, before we start solving, first we need to even draw a dotted line kind of thing, or draw a small battery to make it clear where the battery is going to be connected. Now this figure is complete. We know points A and E, and I have drawn a battery, even though battery V value is not needed for calculation of equivalent capacitance. Now start looking at which are connected in series, which are in parallel. Do we see some capacitors connected in parallel here?
Yes, sir.
Which are the capacitors connected in parallel?
2C and C, 2C and 4C.
So basically, when I look at, okay, how is this connected? Direct connection here, no branch in between. They found an isolated system. And 3C and 4C also directly connected. Are 2C and 4C directly connected? No. The connection here in between is a branch. It means the charge on this plate and this plate will not be equal and opposite. So these three are connected in series. This we identify only after connecting the battery. Now I can replace those three with equivalent one. What is the equivalent? 1 by C equivalent is equal to 1 by C1 plus 1 by 2C2 plus 1 by C3. I find the equivalent capacitance. Of course, it has to be less than any of these three, and this number is less than 1. The coefficient is less than 1, which it should be. Why is the coefficient less than 1? Because this equivalent capacitance has to be smaller than the smallest of the three. The smallest of the three is C. It has to be smaller than C also. I hope all of you following this point. Okay, so I replace them like this. Where would this be connected? They are connected across point A and E. Now I find these two are in parallel, so I can add C1 plus C2. I get my equivalent capacitance. Now they are in parallel, so I get the equivalent capacitance C1 plus C2. So if battery is connected, the total charge sent by the battery will be equal to V times the equivalent capacitance, which is 50C by 90. Now, so if V was say for 19 volts, just take example, suppose this battery had 19 volts charge. Can we find the potential at point D, B and all? What will the potential, if this battery is 19 volts, assuming negative terminal at 0 voltage, what will the voltage of point E here? Same as negative terminal 0, and this will be 19 volts. Now how to find potential across C, 3C and 4C? Potential across these three will be in which proportion? How would, see, potential across these three capacitors are connected in series. Which three? C, 3C and 4C are connected in series. Across the whole set, potential applied is 19. How would this potential be shared? In inverse proportion of capacitance. It will be shared in ratio of 1 by 3 is to 1 by 4, which is equal to 12 is to 4 is to 3. So 12 is to 4 is to 3. How do you divide by 19 in the ratio of 12 is to 4 is to 3? 12 volts, 4 volts, 3 volts. Which will have 12 volts. Potential drop across this capacitor will be 12 volts. Potential drop across this capacitor will be 4 volts. Potential drop across this will be 3 volts. So if this is 0, this will become 0 plus 3 because potential this has 3 volts. This point will become 3 volts. Across which potential drop is 4. So if this is 3, so 3 plus 4, this will become 7. And 7 plus 12, this will become 19. So practice this question, you can easily calculate potential at different points. Okay.
Sir?
Yes?
Sir, can we also say that 2C and C are in parallel connection here?
Which one?
2C and C.
Okay. Luckily you are there, I can't do anything. Otherwise I would want to hit something with your head on the head or something. Which two are in parallel, you tell me how. Let's look at this. Yes, okay. See, let's go look at this. Is the potential at E and potential B is same?
No, sir.
No. So when I look at C and 2C, let me look at. One end is connected to A point. So two plates are connected to A. How about other plate of C? Which potential point it is connected to? B. Which
B,
potential point 2C is connected to?
E.
E. Are they in parallel?
No, they are not.
No, they are not. So it's not because of look or something. That's a test, and it's very simple test. Check, there's a very simple rule we need to apply properly. Okay. Suppose I extend this question. If which capacitors will be in series if battery is connected to B and E? So suppose the question was not between A and E. Suppose the question was one terminal is this side and B and E. Which two capacitors will be in series in that case? These two would have become in series and these two would have become in series. So what is parallel and series depends on which points the battery is connected to. If I ask one more question, can someone answer based on understanding so far? Across which pair of points will the capacitance be maximum? So I can connect across AB, I can connect across AE, ED, BD, diagonal. Across which 2 points should I connect so that capacitance is maximum? Can anyone think of a reason how the capacitance will become maximum? Which 2 points should I connect so that capacitance becomes maximum?
All four should be in series, right? Sir?
Huh?
All four
Hey,
should
this
be
is connection. This is something, see, they're already connected like this ABCD. My choice is only any two combination of points. See, when you connect in series, it will keep reducing. It will not keep increasing. Parallel gets added. See, if
Sir,
I
across
had
D and D?
across,
D and D.
no. Why not? B and D, capacitance will be more than 3C. Why do more than 3C? Because what will happen, this 3C and rest 3 of them are connected in parallel to 3C. If I connect across B and D, what will the equivalent capacitance? Equivalent capacitance will be greater than 3C. Because this 3C plus is something in parallel. Whenever I connect anything in parallel, it will add up. But if I connect across ED, it will definitely be greater than 4C. Okay, this is something you think it over. This is more of a logical question. And
Sir, so D and D is maximum, right, sir?
huh?
D and D is only maximum, right, sir?
D and E will be maximum.
Yes, sir.
One way of, you can calculate all combination. Second way of, think of what happens in different ways. What you have to keep in mind, when we connect in parallel, potential capacitance increases. When we connect them in series, it decreases. And when you connect in series, if any number of capacitors are connected, the equivalent capacitance will always be lower than the lowest one. So using this logic, you can deduct which combination will give you the maximum capacitance. Okay. Now come to some other equivalent capacitors. We'll take advantage of some kind of symmetry. So let some questions maybe like this. Suppose this battery given. Can we easily, if a negative terminal potential is 0, what is the potential of point Y? Okay, so let me pick up one view. Shweta, are you there? Shweta?
Yes, sir.
Okay. Assuming, if I say potential, assuming negative terminal of battery is 0 potential, what is the potential of point Y? What would be the potential of point Y? Assuming the potential at negative terminal of the battery to be 0, what is the potential of point Y, Shweta? What is the potential of point X? How do we find it out? What is shown in red color? What does red color mean? Why I have drawn in different colors?
Potential of Y, sir.
No, why everything is Y. So everything here will have same potential, which is potential of the negative plate. If I take the negative plate as 0, potential of Y is 0. Potential of positive plate is 9. So potential of X is 9. That is okay. How do I find potential of Z? Any clue? Between X and Y, potential is 9 volts. How are these two capacitors connected? Are they connected in parallel or series?
Series.
No, why series? Can I look at these three plates? They are directly joined here without any branch. They are connected in series. So whatever potential I'll apply, in case of series connection, applied potential gets shared. In which proportion? Which will have higher potential, which will have lower potential? The one with higher capacitance, or the potential gets shared in proportion of capacitance or inverse proportion? C is equal to Q by V. So is it direct proportion or inverse proportion? Between C and V is inverse proportion.
Inverse proportion.
Inverse proportion. Okay. So capacitance is in the proportion of 1:2, but who will get, actually it will get distributed in the proportion 2 here, 1:2 proportion here, 2:1 proportion. It means this will have 2/3 of the potential, this will have 1/3 of the potential. So you can do step by calculation, but you can very quickly do in mind also. Potential drop across this will be 6, and potential drop across this will be 3. So we can do this stepwise also, but otherwise we can just practice. So potential drop across 30 microfarad capacitor will be 6 volts. Across 60 microfarad it will be 3 volts. And that will give them equal charge. That's the property of series. So if I multiply 6 with 30, 180 microcoulomb, and this also will be 180 microcoulomb. Both will have the same charge. Now, can we find potential at Z now? It's easy. Potential drop across this is 3 volts. If this is 0, VZ is 3 volts. Okay. The potential of point Z is 3 volts. Similarly, we take one more circuit here. Now it's not 30 and 60, it is 5 microfarad and 10 microfarad. What is the potential at point Z dash? What will be the potential at point Z dash? Sai Shriya? What will be the potential at Z dash? Earlier I have calculated previous case, at Z potential came as 3 volts. Because potential got distributed in inverse proportion of capacitance. What will be potential at Z dash?
Here also the ratio remains same.
The ratio remains same, potential will remain same. So Z dash also, similarly potential Z dash also 3 volts. And so what is determining the potential? The ratio. If as long as ratio remains same, the potential gets divided in the same ratio and potential remains same. This is easy. Okay. Now let's see how we apply this simple thing. Now what will happen? Let's extend this question. So potential is same as long as which thing is keeping the potential same? As long as the ratio capacitances are same and they are connected to the same battery or same V. In that case, it will remain the same. Now let's extend this question. Find the equivalent capacitance. Not together. Now I have given 5 capacitors. How there are 5? We added 2 more here, and we added 1 across here. What is the equivalent capacitance? First thing, start checking every time a method is first. Let me look for something parallel, something in series. Do you find anything connected in parallel or series here? Do you find anything in parallel series? Anything connected in parallel series? See what he had done, what does the colors indicate? All points in blue color are at the same potential. So across which potential this capacitor is connected to? Blue and yellow. Sorry, this colored orange is not distinctly visible. So one is okay. So we'll come to that part. So why 5 capacitors connected? So will the potential of this part and potential of this part be same or different? That's the question. Will the potential, or I have already drawn that one. Will the potential at this point? What is the potential of this point here? We've done that earlier. 3 volts. What is the potential here also? 3 volts. So what is the potential difference across this capacitor?
0.
So this is something, so though there are 5, if potential drop across capacitor is 0, how much charge that capacitor will have? So key point is potential of 2 points across which 20 microfarad capacitor is connected. They will always get the same potential. Even if I replace with battery with some other battery also, doesn't matter. If I replace with any other battery also, potential drop across these 2 points, potential difference across these 2 points will be 0. They will always be at the same potential. So what is the potential difference will be 0. If potential difference 0, it will never carry any charge. If it doesn't carry any charge, what will happen? Will it take any part in the circuit? It is as good as not being there, like so many students also. They are there, but you can remove also, nothing changes.
So,
So
doubt.
so what we can do, we can as well remove this capacitor. So any capacitor for which the potential difference always remains 0, they never carry any charge. What we can do, we can take them out of the circuit. We can remove this capacitor. You understood the reason why it can remove? This capacitor can be removed. Which case it can remove? When this by this ratio is same as this by this ratio. Yes, Asha.
Sir, if it has 0 potential difference, how can it have non-zero capacitance?
No, if it has 0 potential difference across it, will it ever get any charge?
No, sir.
No charge.
No charge.
No charge will flow. So what will happen, though it is connected here, will this branch ever see any charge flowing?
No, sir.
So what will happen, whatever charge will come, directly come here. Nothing will go here. So
Okay.
even though it's connected, actually is as good as not being connected. The charge will not flow into that branch. It's never going to get any charge.
Yes, sir. Got it, sir.
Okay. So we can remove this. Moment we remove, this circuit becomes much simpler. Now, do we spot anything in parallel and series? That's easy. These two are connected in direct connection. I can replace these two with the equivalent capacitor. I can replace these two also with the equivalent capacitor. These are connected in series, C1, C2 divided by C1 plus C2. It will come equal to 20 microfarad. And this will come equal to 10 microfarad. So 20 and 10, and finally both are connected in parallel. So 20 plus 10, I can find equivalent capacitance. Okay. So I hope you understood. When can we remove a particular capacitor? When can we remove? When the potential difference across capacitor always remains 0. It means charge on it always remains 0. In the connecting wire, if the charge is always 0, in the connecting wire, no charge will ever flow. We can as well remove these wires. And same concept we'll come across in next chapter also, which is current electricity. Okay. Now coming to this, suppose 3 identical capacitors are given. All 3 have capacitance given by C. Find equivalent capacitance between point X and Y. Have we defined which point? We have defined point X and Y. So where would battery get connected, or where would they be connected to the circuit? They will be connected to the circuit at point X and Y. So find equivalent capacitance. So I give a couple of minutes. Do you identify any capacitor connected in parallel or series here? Do we identify any capacitor connected in parallel or series in this case? Anyone is smart enough to notice something in parallel or series? Anyone? So let's look at this. Are these two in series? They're not in series. This is the connecting wire, but again, there's a branch. Some charge may flow here. Are these two in series? No, they're not in series. Because what happened? They're connected, and again, there's a branch. They're not series. And these two anyway not connected. So they cannot be in series. There's no direct
So they're
connection.
parallel, right, sir?
They
C
are.
and C are
All
They
three
are
are
yeah. Now we look at parallel. When you look at the parallel from plain eyesight, it doesn't look like in parallel. So what do you do? How do you check parallel? What is the method of checking parallel? Not that they should appear parallel. What should happen? I need to identify the potential point they're connected to. So let me identify which are the potential point they're connected to. So what I'll do, I'll mark those potential points. Sometimes it is not clear, no two are in series. Parallel, let's check. So what we'll do, mark all connectors and X and Y potential. So what he had done, just to make the understanding clear, to all points which are connected to point X, I have marked with black color. All points connected to Y point are marked with yellow color. Now I notice all this wire is black, black, black. So what is potential of this plate? Vx. What is potential of this plate? Vx. What is potential of this plate? Vx. And how about all these are Y points? You all understand? All of them are like one conductor. So what I find, across which two potential point it is connected to? Vx and Vy. Which two potential point this capacitor is connected to? Vx and Vy. Which two potential point this one is connected to? Vx and Vy. These three are connected in parallel. They will always have equal potential across it, equal to Vx minus Vy. All three are in parallel. So mark all connectors at X potential and Y potential. All three are connected to identical potential points. Hence, all three are in parallel. If all three are in parallel, C and C and C parallel is C plus C plus C. Answer is 3C. This was C, 2C and 3C, doesn't matter. It will be equal to whatever sum of these three capacitors. It need not be equal because we have not taken advantage of the fact they're equal. Even if they're unequal also, resultant capacitance would have been sum of individual capacitors. Yeah, somebody has any doubt? They do not look like parallel. How do we call it parallel? You understand reason also? Potential difference across the plates. Any pair of any capacitor, if we take potential difference across the plates, would be same. It doesn't matter which battery, what is the potential of the battery we use. Find the equivalent capacitance between point X and Y. Can we find equivalent capacitance between X and Y? Again, to give a hint, I will go back to this question. Where else we have used 5 capacitors? I have used 5 capacitors here. And this also has 5 capacitors. I'll give 5 minutes. How many of you work it out? You have time, all of you try and get an equivalent capacitance between which 2 points, X and Y. How do we find out equivalent capacitance? See, what I said, the hint was, it is similar to previous question. Let's see how do we solve such question. See what we have done. First, we have marked different colors to indicate different potential points. So everything, this are black color indicates one potential, X, same as X potential. Mark blue color as Y potential. But this part has some different potential and this red color has some different potential. We can give some name to those points. So altogether 5 capacitor, no 2 parallel, no in series. You have 4 unique potential points. Let me call this as X. This point is all Y. All red color are R, and I can call this yellow color as S. 4 potential points. So whenever it is not looking clear, I can redraw the circuit. Let's see how do we redraw the circuit so that it appears a little better. Read are connecting all. Oh, I have marked four potential points. So this is one end is X, other end is Y. This R potential and there's a S potential. There's S potential, there's R potential. Now let's connect one by one. This one is connected across which two potential point? C is connected across which two points? One end is X. What is the other point here? This S has not come. Yellow color is S. So I'll connect this C capacitor across which 2 points? I'll connect across these 2 points. Similarly, 2C will connect across which 2 points? S and Y. 6C will connect across which 2 points? R and Y. 3C will connect across which 2 points? X and R. Only thing I think this S term I forgot typing here. This is S here. So can we reconnect that one? In any manner we can reconnect. So sometimes that gives, if you put it like this, it gives a little better understanding and spot the symmetry. Let's do that. Any arbitrary manner. So what we have done, I started with this first. See how I have connected. One end is X, other end is S. I have connected between X and S. Now let's go for the next one. 3C. 3C is connected between X and R potential point. 3C is connected like this. How is 2C connected between S and Y? And next, how is 6C connected between R and Y? How is 5C connected? Last one left is 5C. Which 2 points the 5C is connected to? S and R. Between these 2 points. Let me connect between S and R. Now when I look at this circuit, something strike me.
Sir, we can neglect 5C, sir.
We can neglect 5C. Why do we neglect 5C?
The ratio is same, sir.
Ratio is same. What I find here, the one which are top here also, whichever potential I apply, potential will get divided in the ratio. This is if this is 2V, this will be V, and this also will be 2V, and this will be V. So always they have same ratios are same. This is 1:2 ratio. This also 1:2 ratio. S and R will always be at the equal potential. This will never get a charge. We can remove this one. Moment we remove, is there an advantage of removing? If we remove this one, does it become easy to solve? Yes, it can be removed. Okay. Let's understand, just to understand this point also. Suppose I potential at point Y is 0, potential at point is X. Can you calculate what is the potential at point S? Potential at point Y is 0. Potential at X is 3 volts. What is potential at S? Can you calculate potential at S? How would this potential? Potential difference is 3. Which will have which side potential drop will be more? Potential at that point will be 1. So it means from here to here, Vx minus Vs divided by Vs minus Vy will be equal to 2C by C, inverse proportion. So this will be 1 volt. Similarly, suppose I tell this potential is 5 volts and this is 20 volts. Can you figure out what is the potential here? What is the potential at S and R? If this is 5 volts and this is 20 volts, what is the potential difference? 15 volts. 15 volts get shared between the two in inverse proportion. Out of 15 volts, this side will have potential drop of 10 volts. This will have potential drop of 5 volts. So how potential drop of 10 volts means? This will become 10 volts. Suppose this is V and this is 3V. What is the potential at this point X? Suppose same thing what I'm saying, either you can do in mind or you can do in terms of formula. How would I do it? Let's see how we can write it. What is this? So let the potential at this point, let this potential at this point be X. So X minus V is the potential drop across C. And this potential drop will be across other one will be 3V minus X. So potential drop across C divided by potential drop across 2C will be in the inverse proportion, will be equal to 2C by C. If we solve, I get the value of X is equal to 7 by 3B. Okay. So parallel series and something up equivalence. Okay. Okay. So this is mostly what we have done, and this covers one major part. I'll quickly what do rather than doing something more. If some part not understood, I'll go through the from beginning again. If anyone is not clear, let's go through that part and see that everything is well understood. When I look at this part starting from what we started with. Okay, I hope this part is clear. Series combination, how to identify. I hope all of you have better understanding, identification of what does series mean. And okay, sum of potential, this is fine. I think this series parallel, all of you are okay. You understood this part also? What would Q depend on? What charge will go? This charge which is going from the battery, one way to understand, or charge is being transformed negative side to the positive side. This Q will depend on the overall equivalent capacitance. This Q depends on C1 plus C2 plus C3. But this Q gets shared in which proportion? This Q gets divided among the three capacitors in the same proportion as their capacitance.